type 2. Fencing types of questions. These questions will usually deal with fencing and will be asked to determine the dimensions that will result in the greatest enclosed area, max area. Turns out that it also forms a parabola when you graph this relation. Okay. This type is the most one of the most challenging ones, right? This type is more challenging. And type 0 or 1. Because it does not provide a starting point. For your table. And I will say this, all regression types questions will always need you to come up with some kind of table. Okay, that's the definition of regression. You need a table with points. And this one, right, does not provide a starting point for your table. Okay. So it's a little bit more challenging in that way. And I will give you some steps here. Step 1, draw out the scenario. Focusing on the fenced in area. I'd like to catch up a little bit. Okay. So some examples here of what it may look like, right? So you might have just a rectangular section that you're trying to fence in which case you have, right? You only write, so we have length and length, width and width, and we only write the letters down where there's an actual fence running along, okay? So you will have instances where you're building something against a barn or something where no fencing is required on that side. You would not be putting a letter down on that side, okay? So that's one scenario. We'll give you a couple more here. So let's say you have a structure or a river or something running alongside one side. So then you technically only need, right? You have two widths and one length like that. Or you're trying to make enclosures, all right, where you're splitting it in half like this and then have two sections that are enclosed, right? In that case, you would have length going from here to here, right? And another length here. And these short sections that come across, those would be considered width. So there you have three sections that are considered the width of this cage, and then two long sides going along here, okay? I'll tell you this, if you're ever building against something, don't have that building or whatever on the width side, have it on the long side, or else it'll be wrong. I can explain that later, right? So that's all I'm going to say to that. And then for each one of these scenarios, okay, for each one of these, the area is always found the exact same width way. You would go length times width for this one. However, the perimeter in this case, right, the amount of fencing required would be found by going 2 length plus 2 width. But the area remains the exact same, right? So keep that in mind like this. Area for all of these, like if you wanted to find the complete area inside of that fenced in section, right? In this case, you would split it in half, but still, if you add up those areas, it's always length times width. The perimeter changes, right? In this case, it would just be length plus 2 widths. In this case over here, the last one, perimeter would be L and L, so 2 lengths plus there are 3 widths here. Okay, so that changes. There are many more examples, right? Just so you know, this is not everything. It can change. You can have like an enclosure with 3 smaller sections inside, 4, it doesn't matter. You can just extrapolate from what you're learning here, okay? Step 2, rewrite the equation of the perimeter so that L is isolated. I just say this, you can also isolate width, but I will not isolate the width as well. Like I most of the time I'll just stick with isolating L just so we are consistent. Ultimately your answer should be the same once we're done with this, right? Step 3, create a table with the following headings. You'll have length, width, area. And remember, area is length times width. Always remember that. Fill in 3 rows, right? You need 3 points. Remember, a quadratic always needs 3 points. Step 4, perform quadreg to determine equation. Read carefully. Equation relating length and area means that length goes into L1, area goes into L2. If it's asking for the equation relating the length and the area, then you'd have to take the length column, like the numbers you're going to have in length, put that into L1, and put area into L2. Area goes into L2 always. Right? Area, that should be area, not areas. Right? Area goes into L2 always. It's just like profit, right? You want area in L2 to make sure you get a quadratic. If you don't get a quadratic, and once you have an equation, I can ask you anything I want, right? Just like before. And it will probably include finding X-intercepts, finding the vertex, finding any point on that parabola, right? I might give you a y value that you need to get an x value for, and so forth, okay? It behaves just like, oh, yeah, the first question is out of 4, yeah, sorry. So I'll give you a little chance to catch up at home. Yeah. The following headings. FF is following, and EQN is equations. That way you just shorten it a little bit for you. Okay. Yeah. Go ahead. And I will add this, right? If length goes into L1, area goes into L2, that means that every point on that resulting parabola will be length and area, and then your graph, therefore, right, will be length, area as well. And it will most likely start here at 0 and go up like this. right? Maximum area is found at the top of the vertex. And notice that, right, the area of my enclosure increases as you're increasing the length, but then there's a point where it actually goes back down. The more you increase your length, the shorter the width becomes until you actually get back to 0, right? You cannot have a negative area. You cannot have a negative length. So again, we're stuck with quadrant 1, right? When it comes to domain. So the domain would go from here to here, and the range would go from 0 all the way to the highest point of the parabola. If you have width area, right, where width goes into L1 and area goes into L2, right, then your graph will just be width, area. It will probably look different, but it will also be a parabola. It might be a shallower or narrower. It's still the max area. This point is still going to be the highest area, but you're going to know the width, right? If you find the x value, which you get from the vertex, you find that particular width that would give you that maximum area. If you graph this and you find the vertex, it will give you the length that will give you that maximum area. We do not do both. We usually only stick with one, okay? So just so you're aware of that, but they can be used both interchangeably, okay? All right, let's do some homework. I'll write the homework down before I do the question, right? Just so you have that in case we run out of time. Pages. I wrote it down earlier here. 18 to 21. This is type 2 and booklet. Because usually I have a feeling that I'm going to run tight on time and I don't want to forget to give you that, okay? And I will post the answer key as well. So example, you are a contractor and you have 600 meters of fencing available. You have been asked to create a rectangular enclosure next to a house. No fence required. No fence required on that side. Bunch of questions. A, determine the equation relating the length and the area. what would be the largest area of the enclosure? What dimensions would result in the greatest enclosed area? Domain and range. Graph. I'll leave it there for a bit. Try to catch up to me before I start. Yeah, I'll take them maybe right now as you're writing this down. Yeah. Go ahead. That's fine. I still like you. It's not that I don't like you. You just have to figure out how to navigate the setup. Oh. I'm just gonna expect you to know that for the test, right? That's all. All right. So let's go through this, and then I can clarify more later if there are any questions. Okay. So as soon as you see fencing or an enclosure, you're like, yeah, this is type 2, right? This is fencing. Where's my study sheet? I have type 2 right here, right? Like, and you're gonna have those steps there, and or not, right? Depends on who you are. So the first thing you need to do is come up with a table. So before you can even come up with the equation, you need a table, right? So we're gonna have a table with length, width, and area like this. Okay. And this is where a lot of students get stuck. They're like, yeah, I know it's a regression. I know I need to make a table. How do I start? Or do I just plug in the 600? Like, how do I start? And this is the challenge, right? You need a starting point. So let's graph our enclosure. So we're making an enclosure, and that's going to be next to a house. So let's pretend this is our enclosure, and I'm going to use the long side and have the house, and this is going to represent my house here. And I'm just going to have something like this indicating that this is taken care of. That side of my enclosure is taken care of. I don't need to fence there. I can save the materials and make a bigger enclosure. So I just have this length on this side, and I have a width on either end of this enclosure. Okay, so really only the sides that are fenced in will get a letter associated with them. Okay. Your next step is to say that the perimeter, right? The perimeter in this case would be length plus 2W. Okay. And P is the fencing available. Right? And that's 600 meters. So just so you know, we're going to replace 600 into that original equation and just rewrite it like this. So after a while, you're actually just going to go jump straight to the fencing available is equal to whatever expression needs to come on the right side, which is determined by this graph right here, right? And so what you want to do is you want to isolate one of those. I gave you the steps where you isolate L. You isolate L here, okay? So isolate L. So L is already there, okay, on this side. I'm going to bring the 2W over to this side. So I have 600 subtract 2 times width. Because if you bring this whole expression over to the left side of the equation, it changes signs. And this is what you're after now. Okay? So that's the expression we're after. Right? I would give you probably a mark for that, for this whole step here. Okay? So length is saying, hey, give me a width and I will figure out what the length is at that particular point. Okay? So what we go and do over here, and you don't have to do the exact same thing I do, but I tend to just go 10, 20, and 30. Like I'm just going to plug in 3 different widths, and I'm going to find the length that would go with it here, knowing that I only have 600 feet of fencing available, right? So I'm going to create my 3 points here by doing that. And this is where it gets a little trickier. So to find the length here, I would have to go 600 minus 2W, right? So 600 minus 2 times 10. And you can do this in your head, right? Because this is 20, so 600 minus 20, that's 580. So if the width is 10, right, my length will be 580 meters. And then you keep doing that. 600 minus, in this case, the width is 20. So 2 times 20 is 40, right? So 600 minus 40, that's 560. 600 minus 2 times 30, and that's 60, right? So this would be 540. You should notice a continuous pattern, right? It's going down by 20. If you don't notice a consistent pattern, something is wrong. You got to go check your work. Also, Mr. Dirksen, does it have to be 10, 20, 30? No, you could do 100, 200, 300. This is called the independent variable. So you get to decide what you want to plug in here. Sometimes if you go too crazy, you get a negative here. Like if somebody had gone 1,000, 2,000, 3,000, you would end up with a negative here. It will still work out. It will still work out. Okay? But don't go too crazy. Just go 10, 20, 30. It works 99.9% of the time. Okay? If like it actually works every time with examples you're gonna get, it works. Okay? So area, what is area? Well, it's 580 times 10, right? I'm just gonna, because remember, it's length times width, right? Area is length times width. So then it's 560 times 20. And I will write down the answers later. And then it's 540 times 30. Okay? And let's go ahead and type this in. The question is asking for length in terms of area. So I can actually go ahead and just say this is L1 and this is L2. Okay? So let's go ahead and enter that into our calculators. And I can tell you, practice, if you go through these questions, you're going to come across some significant issues along the way, and you need to have done this in order to be comfortable with those issues, right? The window and all that stuff, right? So I entered this into my calculator. I'm just quickly going to write these down here before I proceed. you want to take extra care and make sure you got these all typed in right. And then you go stat calc 5 second 1 comma second 2 comma vars y vars, enter, enter, enter. Mine is a little slower than yours. And there's my equation. It's not always pretty. It's not always pretty, okay? It's going to be, some of these values might be very ugly later on. Decimals, what have you. That's okay, right? I picked a pretty example so that we don't have to get caught up on that, right? Remember, if you get some weird number that has an e to the negative whatever, that's often the case with the c value. Some folks just write it down and don't look at the end. There's an e to the negative 7 or something. That means that's a really, really small number, and we consider that 0, okay? So be extra careful. Don't forget the x, right? I mean, you want to forget your x, but not this one, okay? All right, let's move on. We've got our equation, right? B, what is the largest area of enclosure? Okay. Let me continue here. So the largest area of enclosure would obviously be found by finding the vertex, right? So let's go ahead and find that. So I'm going to transition here. Okay. So B, find the vertex. Second, trace max. And we're going to go ahead and find it. Okay, so this is where graphing gets tricky. So I want you to follow my screen here for a bit. I'm gonna go to y equals. Never mind what I have in here. I'm gonna turn on plot 1 here because I'm gonna try zoom 9. Okay, plot 1 is turned on. The equation is pasted in here. So I'm gonna go zoom 9. And it appears that it's a straight line, right? I don't know why mine is so slow. Mine is an older model, folks, okay? So it looks like a straight line, okay? So some students think like, okay, the maximum is going to be up here. It's like, no, you got to change your window, okay? So we're going to go window, x min, I'm going to go -5. Sometimes it's good to go -1, but these are really big values on the x-axis, so I'm going to go min is -5, and max, I still need to increase that, so I'm going to go 1,000. My y min, I'm going to go -5, and I clearly can tell that I need to go higher. So I'm going to go 50,000 just to make sure, right? And let's try that. And there is, see, those are the 3 points you've created. And they're there, and that's what you were zoomed into. So it's just to get you started, right? Then at least you see the graph. So here you have it. Let's find the vertex now. Second trace 4. Enter, enter, enter. And that's 300, right? It's 299.99. It keeps going, so it's 345,000. Okay, look at my screen here. 345,000 is what we're after. And we know that every point is length and area, right? We know that because we typed this into L1 and this into L2. So the maximum area enclosed is 45 what? I'm just going to leave it like that and hope for the best. No, right? Meters squared, right? Because we're in meters, right? Area is always in squared units. I'm sure you know that, but don't forget that, okay? So that's B. Okay, see what dimensions would result in the greatest enclosed area. Dimensions. What is that? They're asking for length and width. okay? They want the dimensions at this point, at the highest point. You already know length, right? Length is going to be 300 meters, right? I got this from B, right? So if you're wondering, like, where did I get that from? It's right there. How would I find the width? Width is just area divided by the length, right? I'm just using the formula for the area and I'm rewriting it. I would have to divide the area, which is 45,000, by the length, which is 300. Okay, and that's 150 meters. Okay, dimensions of 300 meters by 150 meters will result in the maximum area enclosed. Okay, being enclosed. And you could add of 45,000 square meters if you want. Oh, somebody said something, or did I? Okay, was the extra. So that's what they're asking with dimensions. D, what's the domain and range? Range I can go ahead and answer already because it's the lowest point. If you look at the graph, right? The lowest point is 0, an area of 0, and then the highest point is given by the y value of the vertex. So the lowest, smallest area you can have is 0, and the largest area you can have is 45,000, because we're talking about the area, right? And when it's domain, in this case, we're talking about the length, acceptable lengths, right? So we're going to go from 0 all the way to the X-intercept, which is right here. So we're going to have to find that before we go ahead and plug that in. Find X-intercept. And so we're going to go y2 is equal to 0, second, trace 5. There's nowhere before where I have found this info, okay? So you need to give me the keystrokes there. So second trace 5, enter, enter, enter. That's 600, 0. 600, 0, right? So that is the largest, the highest length. In a sense, the width would be 0 at that point, right? So your area is 0 at that point. That's the maximum acceptable value, okay? 320, let's do the graph, and then we're good to go here. And I might just clarify some things. And length in meters. Area in meters squared. Make sure you listen to that one, right? Meters squared. I need to have at least 600 along the x-axis. So 100, 200, 300, 400, 500, 600, 700 works perfect. And then I'm going to go, I need to have 45,000 going on my y-axis. So 10,000 at a time should work. 20,000, 40,000, 60,000. There you go. The scale works. I make it fit, right? 0 here, 600, 0 there. 300 is right here. I'm going to go straight up and go to the 45,000 range, which is right here. And I'm going to include my equation, which is negative 0.5 x squared plus 300x. Yes, I'm going to ask you to practice this and be able to do one of these tomorrow. Yeah. I'm going to just talk about one more thing here. This works exactly the same way as the profit question. For example, if you had an area of, let's say, 30,000, right? There are two instances on this parabola where this area can be achieved, right? So you can have an area of 30,000 with a length of, I'm just estimating here, maybe 140, right? And it could happen again over here with a length of, I don't know, 480. So keep that in mind. Like, I think the homework does mention that. So that's what you're supposed to do there. So this is my plan. So tomorrow's Thursday. I will do just one AC, one question on this type tomorrow. Okay. And then Friday, I would like to quiz you on all 4 types. So tomorrow I want to cover type 3 after the AC, and then on Friday I'm going to quiz you on all 4 types. Okay. And so be ready for that. And then I will probably let you know by tomorrow. I will plan out when our tests are going to happen. Okay. I will let you know tomorrow, and I will tell you how we're going to do that. Other than that, I've already shown you the homework, right? Let me just make sure you have that at home, right? Make sure you write that down, pages 18 to 21 on the booklet.